And here we go again, and welcome back. We are talking today in 3-7 about parallel lines and transversals. We want to, we're going to talk about some basic definitions here, parallel skew lines, transversals, special angle pairs, and then we want to be able to find values using these identifications or these definitions, or in this case, theorems, things we can prove. And of course, we've got a series of definitions that we're going to learn, and really, I would say, as we start to learn the interior angles, exterior angles, consecutive interior angles, alternate interior angles, alternate exterior angles, corresponding angles, these are things that are easy once you understand the definition. So once you've learned it, it's just being able to apply and understand and recognize when we see those things. So you have parallel lines as we get started here. Lines are coplanar that do not intersect. So we will see them somehow indicating parallel lines with a little arrow. And so how would we read this? We have line JK. Remember, it takes 2 points to name a line. Then we have line LM. So we have line JK is parallel to line LM. So this is the parallel symbol, two lines, two vertical lines. Again, doing these two lines is a lot shorter than writing parallel. So being able to recognize what we're describing and talking about. Skew lines are lines that do not intersect and are not coplanar. So here we have two planes. We have plane A, plane B. We have line L, we have line M. So they do not intersect because they're on two different planes, and they are not. The lines do not intersect and they are not coplanar. So lines L, lines M are skew. Parallel lines that do not intersect. There are two lines that do not intersect. Parallel planes are two planes that do not intersect. So here, if we have plane A and plane B, if they are parallel, we know that they will not intersect. Let's see here as we look into some of these. It says identify parallel and skew relationships. So looking at, if I zoom in for these, it says identify each of the following using the cube below and assume lines and planes that appear to be parallel or perpendicular are parallel and perpendicular respectively. So if we say all lines, it appears that this is the shape of a cube or a die. It would appear that, for example, BC should be parallel to AD. We would also know then that FE, if we think about that as a line, that is parallel, and then you have HG back there, and that is also parallel. So all of those would be parallel to one another. Let's see here, thinking about this. If I go ahead and remove this, and I'm going to erase that one in the back. Now talking about, let's see here, skew lines. Here it's saying, hey, BC, all lines skew to BC. BC, let's see here, this line is going on forever and ever this direction if you think about it. The skew lines, they are not parallel and they do not intersect. This line right here, DE, is going up and down and doesn't intersect. AF, up and down and doesn't intersect. EH is below that line and it does not intersect and it's not parallel. And then again, FG, same thing. So there you go. We have trying to look at these, and we'll do some more examples in class where you can see the object in it, because it's sometimes hard to understand what is being written on a two-dimensional piece of paper or image when we're trying to identify a three-dimensional shape. And then the planes that are parallel, I would like to think that, hey, this top piece is parallel to the bottom piece. I would like to think this side piece is parallel to this side piece. So just being able to look and see where they're at in perspective. When we talk about a transversal, a line that intersects two or more lines in a plane at different points is called a transversal. So in this image right here, we have two lines. We have line R and line Q, and they are being intersected by line T. So this is my transversal. And these are just the two lines that we are transversing. Okay, so just being able to recognize that, and we'll have some of these that have special characteristics too. So moving on here. As we look at this, we've identified some of the information. So we're going to talk about interior and exterior. Anytime they talk about interior, they're talking about in between the two lines that are being transversed. Okay, so inside those two lines. Okay, so let me see here. The interior would be this area right here. This area is interior. Exterior is going to be this outside area, because that is outside those two lines. So just keeping that in mind and the location. So then we have consecutive interior or alternate interior. When they talk here, when they start talking about these consecutive and alternate, what they're talking about is the side of the transversal. So that's when we start identifying the transversal here. So consecutive interior angles places the angles inside, right, interior, and then consecutive would be two angles that are next to each other on the same side. Sometimes called same side relationship. So consecutive interior or same side interior angles, 3 and 6. Consecutive interior or same side interior would be 4 and 5. Exterior angles, 1 and 2, 8 and 7 are exterior. They talk about alternate exterior angles. Well, alternating the side of the transversal, alternate exterior, so 2 is alternate and exterior to 8 is alternate and exterior to angle 2. 1 is alternate and to exterior angle 7. Alternate interior angles, 5 and 3, because they are alternating sides of the transversal and they are interior. 4 and 6, alternating sides of the transversal and they are interior. And so being able to understand when I look at an image, I can define it and see what definition am I using. So here, the last thing is going to be corresponding angles lie on the same side of the transversal T and on the same side of lines P, Q, and R. Okay, sometimes corresponding. So I come over here, let me get rid of that. Corresponding angles. When I look at the intersection, of my two lines, corresponding angles are in the same relative location. Here, angle 1, when I see this intersection, I have, like the top left, the top right, the bottom right, the bottom left. So in this, I'm looking for the corresponding location would be 1 is at the top left. I may have just said right and I didn't mean to. Top left. So the corresponding angle here would be the top left. 5 corresponds to 1 because they're in the same general location at the intersection. 2 corresponds to angle 6 because it's on the top right of the intersections. 8 corresponds to the same location as 4, and then 3 corresponds to the same location as 7. So again, I know there's going to be special relationships as we move on, but just being able to understand their locations based on the definitions based on where they are located, or the location based on the definition. So here, looking here, I'm going to start with 4 and 5, and let's see here, 4 and 5. First of all, they are both inside, right? They are inside my two lines, so they are definitely going to be interior. I don't need that, I need this, interior, and since they are alternating the transfers, they're going to be alternating. So I've given you guys a couple of abbreviations up here, and I'm just going to say alternate interior angles is the example here. Using these abbreviations in class, I do not want to write out alternate interior angles every time, so I will use something like this: alt, interior, and the angle symbol. Just some common vernacular for us so we understand what we're all trying to say. So there you go. This would be alternate interior angles. Okay, so as we look at these, just fill them in real quick. 3 and 7 are in the same general location, so they're corresponding. Same side, 3 and 5 are the same side or consecutive interior angles, and then 8 and 1 are going to be alternate exterior angles. So just being able to understand where those are located at. If I were to do a flashcard, I might take a flashcard to learn these definitions, and I simply have this: 2 lines cut by a transversal. If I were to shade this spot right here, and I were to shade this spot right here, what 2 angles, that one side of the card, and then the other side of the card, I would have on there corresponding angles, because those angles correspond to each other's general location. So I don't have to do a lot to make a flashcard to make those useful to me. Okay, so here, identifying transversals. Transversal is going to be that line that both angles reside on. So identifying the transversal. Identify the transversal connecting each pair of angles in the photo, then classify the relationship between each pair. So transversals connecting 1 and 8 right here. They both lie on line F, and 1 and 8 seem to be in the same corresponding location. So they are corresponding angles. Let's see, 3 and 6. 3 and 6 are both on line G. So that would be my transversal. And their relationship would be, they are alternate sides. So we have alternate, and they are outside of the two lines, so that would be alternate exterior angles. Let's see here, then we have 6 and 7. Okay, so they both lie on line E, and then they are going to be consecutive interior angles, because they are in between the 2 lines. So there you go. Just thinking about how do we see what transversals are on, because that's going to identify, do we have a relationship, and then do those relationships. What is the relationship to give us different values? Okay, so here as we talk about special relationships now, that relationship between angles and parallel lines. Okay, so if 2 angles are parallel and they are cut by a transversal, then there are special relationships to those angle pairs that we have previously named. Okay, so corresponding angles in this case, corresponding angles are going to be congruent. So here, let's just say this. When we have 2 parallel lines cut by a transversal, like we have here, 2 parallel lines cut by a transversal, you either have congruent angles or you have supplementary angles. If the angles look the same, 2 and 4 look to be the same size. They are the same size, we're not trying to trick you. Then 2 and 4 are equal. If they do not look the same size, for example, 3 and 4, 4 is an acute angle, 3 is an obtuse angle. Since those do not look the same, then they are equal to 180 degrees. So parallel lines cut by a transversal, if they look the same, they are the same. So let's see here, corresponding angles, just as I'll just highlight one example here. Like angle 1, it corresponds to angle 3. I'm going to go ahead and highlight some more. Angle 8 corresponds to angle 6. Angle 5 corresponds to angle 7. And then angle 2 corresponds to angle 4. So those pairs, as we can see right here, angle 1 equals or is congruent to angle 3. Angle 2 is congruent to angle 4. Angle 5 is congruent to angle 7. And looking at them, now look at some of the things that we know in the past. It looks like we've learned that like 3 and 5 are vertical angles, so they're equal. 6 and 4 are vertical angles, so they're equal. So all of this stuff starts helping us to identify values here. Alternate interior angles. Alternate, again, opposite sides of the transversals. So 3 and 7 are alternate interior angles, and they both look like those obtuse angles, so they are congruent. And then 2 and 6 are alternate interior angles. They are both those acute angles, so they are also congruent. Consecutive interior angles, we are talking about interior in between the two, and 2 and 3 are consecutive interior angles, and 7 and 6 are consecutive interior angles. So they do not look the same. We have one acute, one obtuse angle, so those two do not look the same, so then they are supplementary. They are equal to 180 degrees. So in this case, just thinking about angle 2 plus angle 3 equals 180 degrees. There, we know that. Okay. And then, so that's what we know because they are supplementary. And then alternate exterior angles. So an example of an alternate exterior angle is going to be 1 and 5 and 8 and 4. Those are alternate, and then different sides of the transversal, and then they're outside my two parallel lines. And then these are going to be congruent. This is the acute angle, this is the acute angle. So we know that they are congruent. This is the obtuse angle, this is the obtuse angle. So there you go. And if we were to just plug some numbers in, heck, and let's see here, I'll just do this. Nope. I'll do this. Nope. I'm getting closer. Okay, so I have two parallel lines, right, and they're cut by a transversal. And I'm just going to say, if I know then that, for example, this angle and this angle are corresponding angles, so they should be the same. If I just give any number to it, I'm just going to say 60 degrees. If they're corresponding, I said they're congruent, so this is 60 degrees. If I think about the angle measurement here, this angle measurement, these are vertical angles. So vertical angles were congruent, so that tells me that this vertical angle is 60 degrees and this vertical angle is 60 degrees. And now I have four angles that are all the same. And then if I think about what's going on with the other angles, well, this angle right here should be 180 degrees because it's on a straight line minus 60. So this would be 180 minus 60. So this is 120 degrees. Again, vertical angle, 120 degrees. Corresponding angle, 120 degrees. Vertical angle, 120 degrees. Different ways to do that, but you can identify these features. So with that, looking at this example up here too, I don't know what this is, but I do know if these are two parallel lines, then 83 degrees, this should be corresponding angle, 83 degrees. And if that's 83 degrees, then these angles together are x degrees plus 83 degrees is going to be equal to 180 minus 83 minus 83, and x degrees is going to be equal to 97 degrees. So 97 degrees. And sure enough, if I look, these two together add up to 180 degrees because they're a linear pair, they're supplementary, they're a straight line. 97 plus 83 is going to be that 180 degrees. So all of this stuff is coming in, and we are starting to use the definitions that we previously knew with this new information. And I haven't said it on this video, but I'm not worried about these numbers. Theorem number, theorem number, theorem number. No, I want to make sure we understand what the theorems stand for and how to recognize them. All right, so wouldn't be the same if we didn't try to put some real world in here. So here, using the theorems with parallel lines, it looks like, just looking at this image, I hope we could say, hey, I think I have intersecting train tracks. I hope we know that the train tracks are parallel. So we can imagine that we have two sets of parallel lines intersecting one another. And so it says the cross ties I, this is cross tie I, and cross tie K are parallel. So we have some cross ties here they're identifying. Both cross ties are intersected by cross ties H. Okay, so here's my transversal. If angle 1 is 42 degrees, let's go ahead and label that. Angle 1 is 42 degrees. Find angle measurement of angle 7. All right, if I just think about it again, this should be 42 degrees because these are vertical angles, and then I know that these two should add up to 180 degrees. So angle 4 is 180 minus 42, which is going to be 138 degrees. And I know this is 138 degrees. Thinking about corresponding angles, well, now I know that this angle corresponds to angle 7, so that should be the same. Right? Corresponding angles are congruent when we're talking about parallel lines cut by a transversal, and then this, of course, makes this 138 degrees. This is 42 degrees. This is 138 degrees. So just using those definitions allow us to fill in the information we needed. Let's see here for this check. It says community planning, Dennis Avenue and State Street are parallel. Okay, so Dennis Avenue and State Street are parallel, and they are cut by Newport. Newport Lane along the south side of Oak Creek Park. Okay, Oak Creek Park. If angle 3 is 62 degrees, 62 degrees, well, I know that this should be 118 because those two added together should add up to 180. That makes angle 1 62 degrees. I could look at these many ways. I could say, well, alternate interior angles are congruent, and I could say that's 62 degrees. Or I could say this plus this, or this plus this should be equal to 180. I could do that, but I'm just going to go with alternate interior angles are congruent. So this is 62 degrees. And again, vertical angles are congruent, so I know that this is 62 degrees. Or maybe you just said, hey, this corresponds to this. They're in the same corresponding location. I could have jumped straight there. Depends on how your mind works and what information you need. So what is the measurement of angle 4? And we were able to determine that is also 62 degrees. So different ways to use the definitions to get the absolute correct answer. Here, this is really what we're going to do a lot of this information, these kind of problems here. Use the figure to find the value of the indicated variable. Justify your reasoning. Not worried about thinking. Let's just think about this problem. They have given us angle 3 and angle 6. Angle 3 and angle 6. Looking at the image, those are alternate interior angles because they are alternate sides of the transversal, and then they alternate interior angles. And we said before that alternate interior angles were congruent. Remember, since it's parallel lines, they're both the obtuse angle. So if they're congruent, I know that angle 3 is congruent and equal to angle 6. So then they substituted. The measurement of angle 3 is actually 4x plus 7. The measurement of angle 6 is 5x minus 13. They made them equal to each other, and now they can solve. What did they do? Let's see. They probably subtracted 4 from both sides, right? Or I'm sorry. Let's see here. We're going to go ahead and subtract 4x from both sides. And then subtract 4x. So then we have 1x. Sorry. We have 7 is equal to x minus 13. then they added 13 to both sides, and that's how they came up with x is equal to 20. So if x is equal to 20, we were able to then determine what the value of x was. And then here, another example, find y. They said angle 8 is 68 degrees. Okay, so that's 68 degrees. Angle 3 is right here. This is 3y minus 2. Okay, just thinking about it. Well, angle 8 is the same as angle 5. So I know that angle 5 is equal to 68 degrees. And then now we are looking at these two angles right here are consecutive interior angles, and we said they're equal to 180 degrees. So in doing so, I can turn around and just make those things equal to 180 degrees. And that's what they've done here. They said, hey, geez, this is going to be, some black here, 3y minus 2, because that's angle 3, plus angle 5, which is 68 degrees, is equal to 180 degrees. And I guess I didn't say it, they were consecutive, right? Consecutive interior angles. So combining like terms, 68 minus 2 is going to be 3y plus 66, minus 66 from both sides, and then 3y is going to be equal to 112. Divide both sides by 3, and then y is equal to, did I do that right? Nope. Let's try 14. Right. 180 minus 66 is 114, which should come out to 33, 34, 35, 36, 37, 38. Let's go with y is 38. 114 divided by 3 is 38. And there you go. There's the value of y that would make these answers correct. So carrying forward some of our definitions, introducing new definitions, but in the end, if we know the words, it's really easy, but we have to take the time to learn the words. So we'll just go ahead and get started with this. And again, the big thing to remember when we have parallel lines cut by a transversal, if they look the same, two parallel lines, if they look like the same angle, they're equal. If they don't look the same, obtuse, acute, then they are equal to 180 degrees. And you should be able to look at this and say that's true because this is a linear pair, and that makes them supplemental. They're a straight line, they're equal to 180 degrees. Okay, vertical angles look the same, so they're equal. Again, 5 and 6 would be a linear pair, so they would be equal to 180 degrees. You just got to apply the things that we've been learning. All right, and then there we go. We'll move on.